Okay, so this video is going to talk about kites and trapezoids, so properties of these two different shapes. So kites and trapezoids are both quadrilaterals. The next couple of sections here are all about four-sided shapes, quadrilaterals, and these two specifically are the ones that are not parallelograms. The rest of the ones we're going to be talking about are different types of parallelograms. So first things first here, let's just really quickly talk about, we'll do kites first, so let's talk about what a kite is. So a kite is named because it looks like what you'd typically think a kite looks like. If you've ever flown a kite, something like that, not drawing a very good one here. But the big thing with a kite is that it's got two pairs of congruent sides, and those pairs have to be what we call consecutive. And so the two here are touching and the two here are touching. So we talked about that way at the beginning of the year. So we got two pairs of consecutive congruent sides. That would be our definition of a kite. If you don't have that written down in like a conjecture, or not a conjecture list, a definition list, this would be a good idea at this time to pause the video and add some section in your notes where you've got all of these different types of polygons or quadrilaterals specifically, along with a definition and a picture of what that looks like. So in this case, you'd have one that said kite. You'd write that definition down there for me, and then also include that picture so that you kind of have that to go along with. And we'll do that for trapezoid, parallelogram, rectangle, rhombus, and square as well. Now, that is the definition. The whole point of today's lesson is to talk about what do we know about these things. And so those are called properties. The definition is what it is. The properties are the things that we know about it. And those are different things. So if we were in class, we'd actually do this as an activity where you draw a kite or construct a kite using patty paper. This is a tracing paper. So we're just going to kind of see here. We'd construct half of a kite, and a kite is symmetrical. So you'd fold the paper over and trace it to make that kite. You could do this on regular paper if you'd like to kind of do this along with me here. And then I have the groups, of course, mark the congruent sides. We've got a few definitions here. The vertex angles are the angles between the congruent pairs, kind of like the vertex angle on an isosceles triangle. And then the non-vertex angles are the other ones, right? Those are the ones between the different pairs. So vertex angles there and there, non-vertex angles there and there. We will be talking about those words, and so you need to make sure you know what I'm saying there. So one thing that we always look at here is on our constructed version, what else besides the definition, the two pairs of congruent sides, do we notice are congruent here? And so there's a few different things that we're going to notice. Probably the most obvious is that angle C and its reflection, which is what I have as CR, those are congruent to each other. We could measure them if you wanted to, but again, if you think back to how we made it, if you were in class, how we'd make it is a reflection, and this picture is actually made as a reflection over that line. They have to be the same. And so those are the non-vertex angles. Those are congruent. Other things that we have congruent, if you take a look up here, our vertex angle, our two vertex angles are not necessarily congruent, but if you look at that fold line that we created, it does bisect that vertex angle, and it does bisect that vertex angle. I'm going to put 3 in there. And so we end up with, vertex angles being bisected, non-vertex angles being congruent. And so we've got those two there. We call this line through the middle, you could call it the line of symmetry, but you'll notice I've called it the vertex diagonal. The diagonal that connects the two vertices bisects that in half. Now, you do not need to necessarily know the name vertex diagonal. What you do need to know is that when you split that kite down the middle, you've got two congruent parts, two congruent angles. Okay, so we do talk a little bit about it in class, how we could necessarily prove that is true, but it all comes back to congruent triangles. In a kite, we've got congruent sides already, two pairs. We've also got this shared side in the middle. So we have actually two triangles here that are congruent by SSS. And if the two triangles are congruent, well, then the two angles have to be congruent too. So you can kind of imagine how that proof would look. You'd have a couple of givens from the congruent triangles. You'd have the same segment for B, is it BD and BD, BA, sorry. And then you'd use SSS to show that they're congruent. Now, one thing we're going to want to do here is also to draw in this second diagonal. We'd call this the non-vertex diagonal, if you will. But a couple of things that you're going to notice here. The first one is that those two diagonals are perpendicular to each other. They form 90-degree angles. And the second thing you might notice is that these two pieces here, I'm going to put 3 marks on those, are congruent. And if you think about how we made this, that makes sense. We did a reflection, so C has to be the same distance from that line as the reflection of C. And so that adds 2 more properties to our kite list. We have the vertex angles of a kite are congruent. The vertex diagonal bisects the vertex angles. The diagonals of a kite are perpendicular to each other, and the non-vertex diagonal bisects the vertex diagonal. That's a lot of words. It might be more helpful if you kind of thought of that as a picture, right? You have this picture of the congruent angles in there, and you have this picture of the diagonal stuff going on. But main thing you can kind of think of is a kite, when you draw that diagonal down the middle, is going to be split exactly in half, including that other diagonal, and the two diagonals are perpendicular. So these are your properties. That would be another thing to write down. These are separate than the definition. These are things that we know are true about kites, but they are not the definition of a kite. So those kind of are the difference there. So questions you're going to see on these might look something like this. We've got a kite here, and we've got some missing values. How can we go about finding these missing values? Well, let's start with the sides here. If this is actually a kite, then we know that these two sides are equal. So that would let us solve an equation. If 2x minus 5 and 7 minus 2x have to be the same, well, we get to say that. 2x minus 5 equals 7 minus 2x. Now we can start to solve that. I might want to take care of this. I'm going to add 2x to both sides. Well, that's going to give me 4x minus 5 equals 7. Next thing I might want to do is add 5 to both sides. 4x equals 12. And then I could divide by 3. Or divide by 4 and get 3. X equals 3. So that could be how I'd find x using some algebra there. If I'm looking at finding these angles, the big thing I have to know here are 2 things I have to know. First of all is that A is the non-vertex angle, which means that this one is also A. Those 2 angles are equal. The second thing I'd have to know is that this is a quadrilateral. Its angles have to add up to 360 degrees. If you happen to know that one, or if you just used your formula, 4 minus 2 times 180 is 360. So I can take 360 minus 110 minus 35. And I should have a calculator ready. That would be great, but I don't. Sorry about that. So here we go. 360 minus 110 minus 35 gives me 215. And I know I have to split those exactly in half because each of those angles are equal. So I get 7.5 degrees. There we go. So that's kind of the first thing that we could do. Those are using those angles in the definition to find A and X. Other things you might see here are questions like this. Just finding the missing angles. Here you've kind of, sorry, you got the weird degree symbol in there. I didn't quite print right. But this one all relies on the fact that these in the middle here are perpendicular. So I've got 90 degrees in each of these corners. And I've also got a bunch of equal things. So for example, if I know that this one is 29, I know that this one is 29 because that angle gets bisected. If this one's X, so is this one. And now I can actually just work on the sides that are a little bit easier. If I come up here, I've got 18, 90, and then what's left for X? I can just subtract 180 minus 90 minus 18. I believe that is 72. Down here, I've got 29, 90, and Y. So I just go in here and say, okay, 180 minus 90 minus 29, 61. So Y has to be 61. And finally, something like this, a little bit more algebra practice, because guess what? You're taking Algebra 2 next year. Here we've got the two diagonals shown. And so we know that this vertex diagonal bisects this non-vertex diagonal. And the definition of bisect is that these two are equal to each other. So to solve that equation, we'd be able to set these equal. So anytime you see expressions like that, the first step is always to write an equation that is true based on the picture. You can't just start by trying to like solve something. The equation that is true is your first step. Then we can start worrying about it. Oh, I can add 8 to this. 5x equals 20. Now I can divide by 5, x equals 4. The whole thing relies on you knowing what is true, not just trying to get an answer out of it as fast as possible. So keep that in mind. Okay, so at this point, I'm going to take a pause on this video because we are going to split this up into 2 pieces and come back and talk about trapezoids later on. There's a bell. So what I'd like you to do is, for practice on these, in the book, on page 278, this is section 5.3 in your book, I want you to try questions 1, 2, 5, 8, and 11. So only 5 questions there. I will go ahead and post the answers to this on the Canvas page as well. And then I'll post the second video up along with this a little bit later on. But make sure you're trying those, because the whole point of this is to practice these. This is not, you're not doing this for points. You're doing this to make sure that you understand the concepts and to get a chance to ask questions if you have them.